Okay, so we're going to use the equation of the line tangent to the graph of g of x equals 4x squared minus 5x when x is equal to 1 to approximate the value of g at the point where x is 1.1. So this is how we go about doing this problem. The first thing we're going to do is we're going to find the derivative of g of x. Now g of x is 4x squared minus 5x. And g prime therefore is going to be 8x minus 5. Okay, so that's the derivative, and we need to use that to get the slope when x is 1. So when x is 1, that means g prime of 1 is going to be equal to 8 times 1 minus 5, which is equal to 3. So the slope of our tangent is going to be equal to 3. We also need to find the point of tangency, the point where this line strikes the graph. And for that we go back to the original function, g of x is equal to 4x squared minus 5x. And we've done this before when we were getting equations of tangents. We did all this. Now when x is equal to 1, that tells you that g of 1 is equal to 4 times 1 squared minus 5 times 1, that's 4 minus 5, is negative 1. Okay, now remember the original function, what that's doing for you is that's giving you the y-coordinate of the point of tangency. So the x-coordinate is 1, the y-coordinate is negative 1. So the point of tangency is 1, negative 1. Okay. And we have a picture of that here. We'll just bring it up and then we'll come back. So here is a picture of that. The red line is the original graph, the quadratic graph. The point of tangency is down here when x is equal to 1 and y is equal to negative 1. And I've broken the x-axis up into intervals of 0.1 because we're going to use that in a little bit when we talk about the approximation. So we can see the point of tangency here is 1, negative 1. And everything looks to be in order there. So let's go back. Now we need to get the equation of that tangent. It was already drawn on the diagram that we looked at, but we'd better work it out here as well. So this will be m, and this will be x1, y1. And then if we pull that up here, we have y minus y1 equals m on x minus x1. So that will be y minus minus 1, which basically is y plus 1, is equal to m, which is 3, on x minus x1 is 1. So we have y is equal to 3x minus 3, bring the 1 over, becomes minus as well, so 3x minus 4 is the equation of the tangent. Okay, so that's your equation of the tangent at the point 1, negative 1. Okay, now the question, if we remember back, this question was use the tangent to approximate the value of g of 1.1. Well, we can do this because the original x, where we found the tangent, the original x was 1, and 1.1 is very close to that. So if you're going to use this and expect any kind of accuracy, you have to take a point that's close to the original point of tangency. The x value has to be close to the original x value. So we've got that, and we want to find it when x is 1.1, and all we do is substitute 1.1 in here. So let's try this now. If x is equal to 1.1, y is going to be equal to 3 times 1.1 minus 4. 3.3 minus 4 is minus 0.7. And that's our approximation for g of 1.1. Okay, so let's put that on our graph. Okay, so the point is going to be 1.1, negative 0.7. Okay, and we'll see how close it is to the actual graph. Okay, so we'll draw on this new point, 1.1, x is 1.1. We're saying our y approximate value was negative 0.7. So let's put this on. Okay, and you can see, we'll zoom in here now, and you can see that there's going to be a little bit of separation between the graph and the tangent. Okay, so the little black dot here indicates the estimated value when we use the tangent at 1.1. This dashed line that goes down through the point is when x is equal to 1.1. We said the y coordinate here was negative 0.7. You can't see that because we're zoomed in too far. We don't have a scale, but this y coordinate is negative 0.7. I don't know if we can write on here. No, we can't. Okay. So we can actually go and use a calculator to find what that real version, what the real result is, the real value of g of 1.1, and then we can see what the difference is. Okay, so let's go back. And then this is all a bit of an aside. So let's just kind of the real value of g of 1.1 is given by g of 1.1 equals, what was it? It was 4x squared minus 5x. So 4 on 1.1 squared minus 5 times 1.1. And if you work that out in your calculator, you'll find out that the actual value is negative 0.66. Okay, so our error in using the tangent is the absolute value of negative 0.7 minus negative 0.66, which is 0.04, which is a very, very small error. Okay, that's a very, very small error. So we can use, if we want to graph this and just to see it visually, we can graph the point 1.1, negative 0.66. Okay, so let's do that. 1.1, negative 0.66. 1.1, negative 0.66. Okay, and then you can see it's in burgundy there. Maybe we can edit it a little bit to make it show just a little bit more clearly by changing the color of it. Let's make it this green color. It should show up hopefully a little bit better. Okay, so here is the, if you can see the cursor, this is the estimated value using the tangent, and the point that's on the curve is the actual value when x is 1.1. So it gives you an idea that the separation between them is very small, and remember we're zoomed in very far here. The separation in fact is 0.04. Okay, well, hopefully that was something that you'd gain something out of. Again, it's a long video, it's 9 minutes long already at this point, so it's something you're going to have to go back and look at in smaller chunks. Take your time to digest it. Only do a little bit at a time, and if you're patient with yourself and you're patient with the video, it'll come together for you, I'm sure. Okay, thank you.